be shown by me in different versions, depending on the technology I will discuss, because we are discussing today and next week, and we started to discuss last week the problem of distributed programming. Okay, so the traditional, I will say, Corba one base technique, some ideas of this technique is shown on that screen, but it is quite important to notice that three elements of the process of communication. Okay, so we have a client, okay, we have a server, and of course, the main process of communication is between the client and the server. Okay, because this is the aim. I want to run some remote procedure that will be run on the server, and the results will come back to me. So we have some elements here. I mean, on that screen here in Corba, they are called orbs, but always we need something that will work for us, that will deal with the problem of serializing and deserializing data, okay, because we have to exchange data. And of course, we need some network communication. But we have something more. We have an additional object called name server. Why it is needed? It was embedded in Corba from the beginning, but why it is needed? Why, as we can notice on numbers here, and the first step server registers inside the name server, and then the client resolves something, okay, name, and the fourth step is just the communication. The problem is simple or important, and important still. I mean, let's say I'm facing the problem even today in different technologies, but still the same problem. The problem is that technically communication in TCP/IP networks are based on IPs, okay, ports, and maybe some addresses, names, etc. Okay, so we need some, especially in the case of IPs and ports, some very low-level technical data that are hard to be memorized by humans. On the other hand, just imagine that for some reason, I don't know, some technical changes, load balancing, etc., I will duplicate the server, or I will run the server on the other host. Okay, I was doing such stuff yesterday late night. Okay, I was changing the position of some of my servers from one hardware to the other, because the first one starts to behave strangely for me. Okay, the network starts to behave really strangely. Okay, so I have to move the service from one hardware to the other. Okay, it is easy. I will show you how it is easy in 3 weeks or 4 weeks, but I have changed all the technical details for the communication. So I've changed the IP, I've changed the port. So how to solve the problem that the client could be not aware of it? That the client, it's not me, the client are humans or software really, but run by humans that even don't know that I exist on the earth. So how to make the changes transparent? Okay, the idea is to have something which is called a name server. Okay, so we are naming services. Okay, we are giving them some unique names, unique IDs. Okay, and if the client calls the server, at first, of course, the server has to register its GATS, its techniques with a given name, and then the client wants, I want to call the server called ThermoPL. Okay, it was the stuff I was fighting last night with. Okay, so the only information that is required for the client or has to know is where is the name server and the name of the service they want to contact with. Okay, so the IP of the name server, whatever, DNS of the name server, and the name. It is not something that is strange, I think. It shouldn't be strange for you, because notice how programming is today. In the original, inside the computer, we have addresses, okay? So in assembly language, when you want to call something, strictly speaking, or machine language, okay, you are using addresses. But we know that objects, methods are moving inside the memory, okay, due to different reasons, because we are, for example, creating a new object. So in programming, we are not using addresses directly. We are using names that are compiled to something, okay? And then the processor knows the address physically, okay? But you as a human being, maybe only the case some embedded systems, but in general, in programming, especially in large applications, you don't have to care about low-level addresses. You have names. And it's exactly the same idea. Don't care on real addresses because they could change. They are hard to memorize. And just imagine that you could have 1,000 of services, okay? So knowing IPs, knowing ports is always impossible. It requires some table with information, address, name, or name, address, okay? And in 90s, they were aware of it, okay? That's why we have had a name server. So this is an important element. I will reflect to it. What else we need always? Some communication protocol, some data exchange format, and some interface exchange, especially the last one is needed for the compiled languages, okay? And Corba has a solution to that problem. But there were problems because of timing, okay, because of late 90s, okay. It was designed in 90s and used in mostly the most popular time, but still used, okay, Corba is still used in firewalls, okay, because different ports and no security in the sense of encryption, okay, and that's why new idea came on the market. Okay, so as I promised you last week, I will switch into current century. Okay, so service-oriented architecture, web services, and then I will go further to the most popular nowadays solutions, I mean REST. So the idea of service-oriented architecture became popular at the beginning of our century. And really, microservices, which is the name we are using, could be seen as one of the solution of realization of that very general idea. It was firstly introduced by universities, but soon noticed by industry, and is a core, really, of nowadays programming. On the other hand, I think this is a natural step, okay, because we as programmers have discovered the idea of objects. So maybe before of components, okay, so components, then objects. This is the next step. Let's put objects into the network, okay? So now the components of our applications are distributed, okay? Why distributed? Okay, we have reasons because of a network, because of internet. There is, because it still is a need to develop applications like that, especially enterprise applications. But nowadays, almost even small applications are distributed one. Okay, so we have components, I mean objects in quotation, that are distributed over the network. Okay, originally it was not so component one. Okay, it started with, let's say, one service, I mean one entry to the system or two entries per whole the application. Then it evolved, and nowadays we can notice that even each application is composed of dozens, thousands of sub-services. Okay, but it is just evolution from the idea, okay, we have local programming, then okay, we need a client and the server because our application is composed of two elements, 3 elements, and now it enlarged. Okay, so the idea or the SOA is an architecture model. Okay, so this is the idea. It's realized somehow, and the idea is quite similar in some wording, really, compared or following the idea of object-oriented programming. Okay, maybe slightly different wording, but just a step forward, step to move everything to the network. Okay, so the idea is, okay, so I have a good information that I have changed the slide, but still I think not these slides I am talking about. Okay, thank you very much. This is always the problem of the remote. Okay, not always. Okay, so the question is, do you see the slide and title defined?
Yes.
Okay, so thank you very much once more for the information. Okay, it happens, but I remember the same lecture in reality. I mean, at the university, and I was just talking to students stating, okay, just notice there is a red curve with some information. And then I noticed that they are just staring at me in a different way. Okay, and I turn around and notice, okay, it was red on my laptop, but there was no red color on the university projector. Okay, RGB was not working correctly. Okay, so it happens. So software-oriented architecture is a set, or the idea that we are grouping business functionalities, okay, and encapsulating them. Okay, so just encapsulation. Just notice hermetization. Encapsulation is the first idea of object-oriented programming. Okay, so it is more or less in very abstract way the same, but what is important that it is placed in the network, so that components has to be self-contained, like objects, distinct and reusable units. Okay, so the same idea we have behind objects, but now we are calling them services. Okay, and originally they were representing a high-level business concept. Okay, nowadays it goes down, down, and down. Okay, now everything is a service. Originally, in service-oriented architecture, it was connected with a high-level business concept. I mean, I want to create an account. Okay, this is the service. A lot of different small subtasks has to be done, but this is the service. I'm doing something, especially a service from the point of view of users, human beings behind. Okay, services can be, they don't have. Very often we have services and they are running on the same hardware, but from the origins, they can be. Why can be? Because distributing over the network sometimes is really needed. On the other hand, it allows, for example, the tricks that I was showing to you last week. I mean, load balancing. Okay? It's based on the distributing. We are multiplicating the hardware, we are interconnecting. So if we have software ready to be distributed over a network, it gives you advantage in the future. Okay, if there will be need, you will have it. That's why, for example, the quite old technology even behind the idea of service-oriented architecture, I mean Java Enterprise Edition, which is based on the CORBA, by the way, all those components, they are called Java beans. Okay, Java Enterprise beans. Really, they can be distributed over the network from the scratch. The communication between those components are based on the CORBA, even if they are on the same computer. They can be easily distributed. So this is quite important aspect. And the other aspect, that the word I was using on one of my first slides last week, reusability. Okay, because the solution to problems enterprise application designers face is to use the same stuff twice, 3 times, 4 times, as many as possible. Okay, so the idea is that we can reuse these components to create a new business application. Okay? So air money. Okay, and what was the quite interesting aspect of original service-oriented architecture, that is not fully or not realized really in case of REST. Okay, I will come back to it when I will compare these technologies, is the idea of the contract. Okay, so the SOA has the idea that the communication, the contract, the specification is described. Okay, so how we can do it, what we can do it, etc. Okay, so services are autonomous, discrete, reusable units of business functionality, exposing its capabilities in the form of a contract. Okay, so we have contract, we are defining what we can do, formally defining. Okay, and they could be independently evolved, moved, scaled even in a runtime. This is other very important aspect. Or okay, it was the idea described by university guys. We have a lot of ideas. Sometimes they are stupid, some they are very clever, but they are not used. And that idea became very, very popular, and for a lot of time, of course, in the past was quite hot. Okay, so why SOA? Okay, just to enable flexible federated business processes. Okay, I was showing you quite similar picture even today. I was not discussing it. It was slightly discussed last week about this ops. So okay, now we change the name from op to service, and okay, maybe some new wording, services became a word popular. And this is the idea. Okay, so it was not evolution, it was not a revolution, it was evolution with new techniques behind it. Okay, so our company software is logically, sometimes physically divided into some elements that are exposing some business services. We are selling tickets, we are identifying elements, and an application from the point of view of the designer or the user is a set of services, interconnecting services. Okay, and so if I need to do something new, some elements are already developed. Okay, so for example, identification is a part of the service. I could identify our users. Okay, so okay, we are doing it. It should be obvious that for you that this is like we are developing software, but it was a change compared with the previous ideas. Okay, so reusability, aggregation from multiple providers, like here, for example, I'm buying tickets for my company, so I'm checking several services of different providers, okay, and then selecting the cheapest solution, or I don't know, the fastest, the shortest connection, etc. All the information is gained by the same technique, by services. Okay, so in 90s, before service-oriented architecture, the most popular solution was so-called a three-tier architecture. Okay, so we have a front-end based on HTML, some backend, I don't know, PHP, for example, language, and databases. They were really homogeneous in the sense that were strongly language dependent. Okay, if I wanted to enlarge the system to add its new functionality, I have had to just know PHP and add new things. Okay, the change from one database to the other was very hard. Okay, so they were centric, and only HTML pages was allowed as the front end. The next step we are talking about, service-oriented architecture, could be heterogeneous, because we are defining just protocols and the way of communication. So the elements that are communicating with other elements could be developed in anything. Okay, so I could have a part of the software developed in PHP, and after next year I have new developers that loves, I don't know, Java, then they are loving C#, now Python, for example. And this is not a problem, okay, because the communication, the interchange of information is defined, so it doesn't really matter what is the software behind it. Okay, so it is language independent, distributed from the design, from the beginning. So it is very nice. The other element of this technique was a popularity of Ajax, rich internal applications on applications based on, HTML one based on XML HTTP requests, so asynchronous one, and it also was one of the reasons why the service or the architecture was developed. It requires some techniques on the front end also. So it has a lot of principles enumerated here, very general statements like abstraction, autonomy, statelessness, okay, discoverability, okay, ideas, how to realize it, okay. Technically speaking, it was realized mostly by the techniques which are named like SOAP. Okay, this is an element of the name. This is a triple SOAP WSCDL UDDI. This is the solution to the problem. I mean, how to communicate HTTP or HTTPS, how to exchange data, XML, because the beginning of the century, and how to describe the contract, XML language, WSCDL, based heavily on XML schema. Okay, so the idea of web services was a machine-to-machine interconnection, okay, interaction. The SOAP was not aimed to have a direct communication with humans. Okay, we can make it indirectly. Okay, for example, we have browsers, okay, that convert some data into human readable graphics, but this is not a user interface idea. Okay, this is the idea of communication elements between elements. So we are making a platform, programming independent, distributed over existing web standards. It was a very important aspect that when the technique was proposed, HTTP was existing for the many years. HTTPS as a security, and XML was the most popular technique during the time for serialization. Okay? Nobody was talking about JSON. So all elements existing on the market were put it together, and we have had a solution. Okay, maybe it's not the best picture, but even the traditional free tier application could be now somehow connected into the web services base, because all elements are not communicating directly using some defined protocols. They are communicating through the SOAP-based techniques. What is important that the usage of SOAP-based ideas could be done in 3 different ways. It could be something which I was talking last week, so remote procedure calls. It could be done in a style I was trying to describe, and you will notice techniques behind the ideas soon. I mean, service-oriented architecture, and we have a third approach, which is quite popular nowadays and is connected with other architectural style, I mean REST. So the idea that everything is a resource and we are transferring some representations of the resources, but I will talk about it soon, I mean today. So the idea how it was or still realized, but it's not so hot, not so popular nowadays. So the idea was XML as a language to transfer data. Okay, so this is a language text-based one. Okay, somehow similar to HTML, because the XML and HTML has a common parent, a common father or mother. I mean SGML. And for a large time in the history, from 97, 98 till 2008, XML or HTML was forced to be XML. We have had a standard called XHTML. But XML is a standard for transferring data. I will not talk a lot about XML on today or the next week, but a short comparison between JSON and XML would be given by me next week. Okay, so we have a set of protocols or set of standards, very heavily defined, very strict one. Okay, this is one of the advantage of that technique that allows to solve most of the problems. Okay, so we have a UDDI that's nowadays is not used at all. This is the idea of that name server, and most of the public UDDI's nodes were closed many years ago. Okay, but it was a nice idea. It works like an internet. If I want to buy something, I'm checking internet inside the internet prices. Okay, so I'm using some portals, Amazon, for example, and others. I'm comparing prices. If I know exactly what I want, okay, I'm checking prices and other features. I don't know, the timing of delivery, etc. And I'm selecting the best solution for me. And the idea was the same. Okay, the idea was that if I need to do something, I don't know, to calculate the p-value. Okay, stupid example, but an example. Okay, so I'm checking UDDI which services available publicly are doing that stuff. Okay, and I'm selecting the best, that one that fits to my need. Okay, according to some reasons. So UDDI was a collections of all web services publicly available on the earth. Okay, but it was not working like that in the practice. I will come back to it soon. Okay, the SOAP, Simple Object Access Protocol, it is the core of the service architecture XML1s. Okay, so this is the format of the messages, of course, based on XML, and really the software has to convert over data into SOAP once sent through the network, and then decompose that message into, I don't know, Java data, do calculation, and then again convert it back. Since we wanted to have UDDI, so we need a description. On the other hand, we need a description of the interface, because we as a programmers are natively programming, not in XML. We are natively programming in C#, Java, C++, etc. So we need interfaces. From the point of view of Java language, to call something, we need a class name, name of the method, types. Okay, if the types are basic types like numbers, integer, like strings, it's not a problem. But imagine that we want to say send the data like, I don't know, the university teacher. Okay, what is a university teacher? I don't know, name and some other stuff. Okay, it's capabilities, it's age, whatever, the color of his or her eyes. Okay, I'm joking. So if we are really calling, just look at your code. Okay, if you are sending some objects, references to them, we are sending some sophisticated data. Okay, so if the other word plans to use it, he or she has to know what is inside. So we need some standards that will put the data that we have inside the interface. Okay, so we used, or they used, XML and XML schema, which is a standard for defining types in XML. Okay, and XML schema is very strict. It's similar to interfaces. Okay, so we can define any data types we are using, and it was still not very much, but it was very popular during the time web services were introduced. Okay, so everybody was aware of XML schema, and we have had a technique which is called, or still have a technique For example, in dotted environment, XML serialization, and automatically converts XML schema into classes and classes into, or interfaces, strictly speaking, into XML schema. Okay, so it was done automatically. A lot of details, some of them maybe with you I will talk about during the next semester, but the main idea was, okay, it is a sophisticated technique, but it is done automatically. Okay, so we have, let's say, as a side effect, some automatic translators that allows us to translate the interface from Java to the interface into, for example, C++ in magic way, okay? Or into PHP, whatever. Or maybe into PHP, it was not needed, maybe from PHP to Java, because PHP is a language which is not based on types, okay? So it doesn't require for proper work the interfaces, but it is nice to know what should be called, okay? So interfaces at least are needed for humans, okay? So a lot of the idea was, again, just select things available on the market: XML schema, HTTP, HTTPS for security, put them together, wow, and service-oriented architecture is working, and make it popular, okay? When it's popular, everybody's using, the others are also forced to use, and it was a perfect solution. Why UDDI was not popular or stopped to work? Because in practice, SOA all that idea was not used for communication between companies, or is used, but the hottest area was integration inside the component. So we're not using services from the other world, from China, Russia, etc., which some, I don't know, security problems, etc. Everything was done at least around 2005 inside the company. Okay, it was, I mean, that web services was a solution to the problem of integration inside the company. Okay, so just look again, 3 elements, slightly different naming, but still 3 elements and doing more or less the same stuff. So the service provider registers its functionality, so sends the WSCDL standard stuff. I am capable of doing that, and that, etc. It is registered. So when a client wants to do something, has to contact with the registry, gets the WSCDL that just describes all the techniques, but also describes where is the service provider. For HTTP, as for other network connections protocols, we need things like IPs of the service provider and the ports of the service provider, okay? So still the same problem. And now we are not using the ORP strange stuff. We are using SOAP strange stuff, but it's not so strange compared with ORP. Why it's not so strange? Because SOAP is based on XML, and XML is a text. So it is human readable, okay? Maybe not natural language, but this is a language, formal language, okay? So at least me, as a guy who teach XML, who use XML even today. For example, yesterday I was giving a presentation to some group of people, mostly from humanities. I was talking about TII, XML-based standard for storing text with some structure inside. Okay, so I was trying to, let's say, force them. If you are doing any works on text, for instance, there were guys that were working on romantic poems in Polish, okay, and they have problems that the texts are not, let's say, they have different layers, okay, because for example, Mickiewicz, quite famous in Poland, a writer from romantic time, okay, he also, like Słowacki and others, were changing their text in time. Okay, so we have different versions. So how to store such information inside, or how to store information that we have a new line, or we have a new acapit, etc. Simple things, but if we preserve such information, we can get some more information from it. And I was advertising some of the standards based on XML. So, okay, XML for us as a computer engineers is some ugly old stuff, but for others from the outside world, far away from the techniques like humanists, XML is a new discovery after 20 years or even more. Okay, so SOAP solved the problem with the firewalls. Sorry for the Polish part, but I told you I was mixing my slides from Polish and English one. Okay, but okay, SOAP always. We have firewalls, and HTTP is the most open port on the earth. Okay. Everywhere, so it solves the problem with firewalls, the problem with security with adding S, so the subjects of Dariusz part of the lectures. So everything was working and is working. Okay, so what are the guts? What we have inside? Nice for me, maybe ugly stuff for you. I mean XML, and we see here the advantages of the solution and also disadvantages of the solution. Okay, so this is a stupid example because the service does simple things. I think it adds, okay, add two elements. Okay, so maybe this is not the best idea to use web services, especially SOAP one based for such simple elements. Okay, from origins, the idea was that we have a industry one enterprise application with few SOAP interfaces. Okay, so it was designed for business one functionalities. Okay, adding numbers is not a business functionality, or could be, but it's a very simple service. Okay, from that sense, so that extra information that is required here. Just notice I have to send two numbers to be added, and okay, it's human readable because it's XML. It's nice because I could just look on the results. I could produce the request by hand, okay, because it's human readable, at least for the humans need some background information. On the other hand, it is a self-described element. Just notice, we know now this is float, the name of the function we want to run, even we know it is float in which sense. Okay, we are extensively using a technique which is called XML namespaces. So we have prefixes XSDE, and the prefix is defined here. So the endpoint knows that this is not just a float. What does it mean, float? That has different meaning, right? Floating point numbers. This is the idea we have inside my memory. But for non-computer guys, the wording could mean something. So it is, everything is very, very strictly defined. Okay, so this is float number in the sense of that standard. Okay, so I know what does it mean, or the machine could know what does it mean. Okay, the format of encoding, etc. What's the problem? Why the text-based communication and such stuff like definition of everything? We want to connect different words. We want to connect Python with Java. We want to connect processors like RISC-V with processor from Intel. They are totally different. The same binary representation of numbers are different on different architectures. So if I will send the float as bits from one computer to the other, it will be different, or it could be different. Even integer numbers could be different. Okay, we have little endian and big endian techniques. Okay, so just sending just bits, serialized data as they are stored inside the memory and sending them over internet could result in a disaster. So we need, even for low-level data as numbers, some standard, common standard. And text-based, human readable, was popular during time, still is popular text-based, JSON, okay? The most popular now standard, at least among computer engineers, so among applications, is also text-based one, okay? Maybe not so heavily based on some external elements like namespaces, etc. It is, okay, I will say that XML is like Java. I mean, very exhaustive language, but a language that compiles fast and everything is defined. And JSON, we'll switch to it soon, is like Python. Nice language, just don't need to write so much, but it is for well skilled programmers because it could be used wrongly, okay? So the response, okay, you see at the beginning, this is the part which is coming from HTTP protocol, okay, because we are extensively using HTTP protocol, okay. So so this is the post response in the sense of HTTP protocol, because HTTP allows to send any data, okay. So we use content type to describe what we have inside, okay, and XML again, and the solution again, a very exhaustive. But on the other hand, just taking into consideration the fact that we are using TCP/IP network, so we are using packages. So if you are sending 1 byte, and then nothing for a long time, and you are sending 1,000 of bytes, it's exactly the same problem because we have packages, okay? So they are packed into some sized of defined size elements, okay? So 1 byte, 10 bytes, the same problem, the same amount of data to be sent, really. One package, okay? So, and it was not so often sent, okay? Originally, it was web business services, okay? So how often you are creating an account, okay? 1 per second, maybe. So this is not the problem. So SOAP, Simple Object Access Protocol, as you notice, is XML based, therefore platform and language independent, simple, maybe for me, extensible. Why extensible? Because XML is an extensible markup language, okay? So it's extensible from the name, from the design, of course. Since it is using HTTP, it is stateless. Okay, we could achieve some states using techniques or tricks known from HTTP. I mean, for example, sessions, some IDs. Okay, so but from the scratch, it is stateless. Okay, but applications therefore can create more complex interaction patterns, and they were creating because stateless communication is not always enough. So the construction of the SOAP consists of the envelope, header, body, and fold. More or less like HTML. We have HTML tag, header, body, but also it's obvious that we need such elements. Okay, we have some container, we have some extra information. So header, we need body, call to response, and since we are talking about programming, we have exceptions. Okay, so if an exception will be right somewhere on the server, that information has to be sent back to the client. Okay, so we need a part of it, which of course is optional, but because not always false happen. Okay, so slightly more sophisticated example. Okay, that's still simple. We have an envelope. Okay, we have a body, the method get price of apples. Okay, so more business-oriented example now, because it could be seen as a functionality. Okay, I am a service which provides some prices of some food. Okay, WSCDL, again a standard connected with SOAP. Again XML1. But the aim of WSCDL is to describe or self-describe, because it's provided by services, its functionality. Okay, so all the technical stuff, types, names, has to be put there. So it's like an interface from the sense of programming languages, and there are a lot of in each compiled language, the language based on types, heavy type languages, there are automatic conversions from interfaces into WSCDL and vice versa. So from the high level, it is a kind of the documentation for the distributed system. And what is nice, that the documentation is run automatically, okay? I hate to write documentation. I love to write code. I love to type in a formal language. I hate to type in a natural language. Okay, I love to analyze natural language, but not write, okay? So when I have to prepare a documentation, it's a nightmare for me. Why to waste my time? And what's nice behind that idea, the documentation is, because okay, I understand that it is required, but I don't want to do it by myself. But what is nice, on most of the modern solution, maybe in early ages, it was not like that, but soon, 202 or 203, it was produced automatically. Okay, so it defines services. Services are a very high-level aspect, but also has a lot of technical aspects. So services, from the point of view of the SOAP, is a collection of endpoints. So we can see them; those are ports, and it is used for exchanging messages. Okay, so we have messages. So we have to describe this. The message could be seen as a data. Okay, so we have to define what is the construction of the message, types, subtypes, okay, the structure. And port types are collection of operations, okay, because we have, if we, on the endpoints, most class, you will notice next week, going to examples in real programming languages, endpoints are, at the end, some methods, okay? So some operations to be done on the servers. So in WSCDL, they are called port types. And we have bindings. So this is a really sophisticated standard, very exhaustive. But what is nice, you don't have to do it by hand. It's done always automatic way. Okay? Why it is so exhaustive? Why it is so sophisticated? Because this is a Latin of the SOAP world. Okay, this is the language that all our English. Okay, I'm not a native English speaking person, and most of you are also not. Okay, so we need some interchange format that is understood by everybody. Okay, it's nice because we are human beings and we are using native languages. In most cases, quite similar. Okay, different wordings, different grammar, but more or less all humans are using very, very similar languages. But here we have more sophisticated word. We need to talk between Java and Python. Languages coming from totally different words. They have to talk to each other. That's why it is so sophisticated, because it has to be done automatically. Okay, so all cases has to be considered here. Okay, so the idea is that service provides some services. So it has ports, it has messages. Okay, so and the message consists of some elements, types, etc. So all those stuff, all these techniques has to be described in a formal language as WSCDL and therefore XML and XML schema is. Okay, so maybe I will skip some of the details. It could be boring, and it was evolving in time. Okay, so this is the schema of that language. You can notice how it is sophisticated, different possibilities, etc. This is an example of the, not whole the WSCDL, just a part of WSCDL connected with the SOAP I was showing you previously. Okay, so the name add types, okay, functionalities, etc. It was extracted, I think, as far as I remember, from the Python, from the PHP base one web service. That's why we have encapsulation of the doubles inside math output, math input, math interface. So, okay, it is very exhaustive. You can, reading it, have an imagination what is the purpose of WSCDL, but I repeat myself again, it does not matter, because it is, everything is done in an automatic way. So that's why the language is so exhaustive, because we are exchanging some lines from the PHP into lines, for example, of Java. They then will be more readable, okay? And this is something internal. So we could use WSDL in two ways, okay, depending on the language we are using. So during compilation, okay, so if you have to develop a client web service, you are downloading it, because each web service that is SOAP one base has to have WSCDL, and you are downloading it and running some script available on your computer always, because it's available everywhere, or almost everywhere, let's say. And it converts that ugly, exhaustive WSCDL XML base one stuff, okay, with XML schema, into nice, I don't know what you like, C# code, okay? So we have now interface from the sense of the programming language, and it's like local programming, okay? In case of languages like Python, for example, PHP, so script one, it could be done on the fly. What I mean by that, the languages are not so heavily based on types. So the type is just a collection, it's like a dictionary, okay? It could change on the fly. So in those languages, the description is downloaded during runtime, and the conversion from that strange SOAP base one text into Python dictionaries are done on the fly. Okay, so as we are using WSCDL, it really speeds up the development of the code, okay? Because sometimes students in the past, when it was a hot topic, were asking me how to develop a client in SOAP techniques. And my answer was, press two buttons, okay? It's very simple, because everything could be done automatically. So we have scripts in all environments, and especially in graphical base one IDEs. You just pressing a button at an endpoint, you have to put the address, the only stuff, pressing the second button, blah, 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 blah. Things are downloaded, WSDL is automatically converted to Java code, webs, and you can call it from the line. Okay, you are developing a web service. How to develop a web service? I will show you next week. Easy, you are just coding and adding some extra annotation, because annotation are popular nowadays, okay? So and that's how you have to do it. And WSDL is automatically generated, okay? So it is nice. You can notice sometimes on my slide that I have a lot of spelling errors. So you can imagine how hard for me is to code without with languages like Python that are not checking the correctness during the compilation. There's no compilation time, or it is hidden, let's say. But in Java, yeah, putting object dot, and you have the list of all possible methods were coming from WSCDL. Okay, and then you have a list of required types for that argument. Okay, so it's like a local programming. it's simple. So even now we have distributed application, but switching from or adding such capabilities, it is simple from the point of view of the coder. Of course, a lot of technical, sophisticated stuff behind it, with some side effects. Okay, we'll discuss them: XML, exhaustive language, etc., etc. Okay, so as it will be, I hope, shown by me next week, deployment of the server or the client, or development of the server or the client based on web services is totally simple, because they decided to use already known and used standards, because WSDL is heavily based on XML schema, and it was popular, and there were tools for converting stuff. JXB, for example, in Java. Due to HTTP problems with firewall announced by me last week in the context of RMI, for example, or Corba, disappeared. Security disappeared. We have S. So we can do heterogeneous application, fast, simple. So we have solution to most of our problems. Disadvantages. The main disadvantages is a side effect of its advantages. So I mean the size of the messages. SOAP in XML. XML is very exhaustive, but SOAP adds some extra requirements to XML. So at the end, as you noticed, probably, if you were not sleeping, looking at my previous slides, you noticed that they are very, very exhaustive. It costs. You have to convert them automatically. And it costs, especially this is the problem in embedded systems. This is a problem when we have a lot of messages per second. And this is a problem in JavaScript, which was not a fast language, and still not a fast language. It requires a lot of memory, and it is slow. It's much faster than it was 10 years ago when the SOAP was popular, really. So you can imagine how it was terrible to use SOAP inside JavaScript. It was easy in the sense of coding, but it was terrible in the sense of the usage of memory. The only applications that states that there is not enough memory on my computer is a web browser, okay? Because I'm heavily using it. On the other hand, JavaScript is a terrible language of memory management. The other problem that was at the beginning, but soon, I mean around 2010, 2015, disappeared, okay? Because originally the SOAP was connected with enterprise servers, okay? So if you want to use a SOAP technology, you need to use Java Enterprise Edition servers. You need to use Microsoft servers, which, okay, it was not a problem at the beginning because the SOAP was connected with enterprise-based applications, okay? So the applications were already developed in such environments. So there was not a problem to add some extra functionalities to heavy Java EE servers. But soon people wanted to just use distributed programming everywhere, even inside applications, okay? I want to measure the level of the Wisla River somewhere, okay? For example, in Włodawa, on the border with Białorussia of Poland, okay? So I have some equipment that sends data each minute, okay? How to send data? No, maybe you SOAP. Oh my God, I need to use some Java Enterprise server, okay? This is terrible stuff. Okay, it was solved, but meantime, we have much more simple solution. I mean, REST-1, okay? So REST-1 idea that was evolving in time. It originates even at the beginning of our century or in late of the previous century, but let's say became more popular than SOAP. Let's say around 6, 8, 10 years ago started to become very popular, and now is the core of our programming, at least of my programming. So compared with the previous technique, on one hand, it solves more or less the same problem. I mean, the problem of distributed programming. But some ideas are different, and the biggest difference is in the second sentence. Okay, because SOAP, WSCDL, is a standard. It's based on XML schema, XML. REST is a style. So on one hand, it's nice. You can do whatever you want. I'm using REST without HTTP, and I'm still naming it REST, okay? Yeah, I think it is okay. Because it's style, you can do whatever you want in following some ideas. So it's nice and it's bad, because sometimes without some extra knowledge, documentation, it's hard to write a client, because not everything is described. Okay. The origins of REST and popularity of REST comes from two sources. One source is things similar to the stuff described by me previously. So distributed programming, so usage of HTTP. The other source are web pages. And around 2005, 2006, the idea of links in web pages changed. I mean, in the past, link was just identifier, okay? Sometimes we use some stupid characters, not human readable. But if you nowadays access, I don't know, Amazon, Allegro in Poland, and that kind of stuff, usually the links, the part of the links have meaning. If I want to buy some shoes, I'm putting the name shoes / something, okay? And it works in magic way, okay? So due to different reasons, links became an information for even for humans. They have names, human readable names, and they are describing resources, okay? So if I want to access something, I'm looking for something, I'm just adding slashes, okay? Sometimes, of course, it's hard to know what should be next, but we have links. But I'm pressing shoes, sports shoes, I don't know, Adidas, whatever, okay? And I have links. The link have names, and each one access resources, some data, okay? So it is the idea of the REST. Everything is a resource, okay? So, of course, again, use existing standards, okay? And the next one. And that's why I think it became very popular. So the client-server communication, stateless, since it is mostly based on HTTP, okay? So each request from the client to server must contain all needed information, because it is stateless. We don't know if it's the same person or not. And the idea is that clients gets data. The client pulls representations, any representation. I don't know how are you familiar with HTTP, but HTTP from the beginning has a technique. It's text-based, so if you don't know how it works, just open your lovely web browser, press F12 in most web browsers, see the some nice or not nice windows, and select the network, okay? And then you can notice, pressing on each call to the server, how the request is constructed and what is the response. And you will notice that the client, even in just normal, typical web page, is requesting something, is static. I need something that is HTML. I need something that is JPEG. I need something that's in a given format. And at the beginning of the response, I have the answer. The answer is in. The answer is in, okay? So and what else we have inside HTTP that I could ask for different representations, okay? Just talk to me in Polish, English, or French, okay? This is slightly a joke. Just give me the answer in HTML, or maybe in XHTML, or maybe in text. And the server selects what is he capable of. Okay, so he has also to inform the client what is the language, the format of the answer, and it is built in inside HTTP, and the rest is heavily based on that ideas. Okay, so we have layers, and all the techniques, all the tricks like load balancer, proxy servers, cache servers, known for web pages, could be used here. So it's really, it could be seen the rest as a step forward. I mean, the client, original client of HTTP, so it could be seen even each HTTP page, even that one developed in early 90s, and web server as a kind of the REST service, okay? So because they are REST service, everything available by HTTP is a kind of the REST service. But what changed in time, that we are not just sending the HTML pages, CSS, JPEGs that are that were developed for humans to be presented on the screen. We can send anything, okay? Because just stating, okay, I want something in XML, I want something in JSON, I want something in CSV. Why not? It was available even in 92, such tricks, but were not used. Okay, so suddenly we moved out the web browser from the communication, or not move out. It was still existing there, but we add some new clients based on other techniques. Wow. And now we have a distributed programming. And it is so simple, so nice, that even each application is divided into subcomponents based on the techniques, and we have microservices, and everything is a microservice nowadays. Okay, but let's come back to the idea. The idea, good word. Why idea? Because it's a style. Okay, so a lot of flexibility. So idea is as follows. Okay, that we have inside HTTP some methods. The most popular get, and then post, and then quite rare put and delete, but we have even more. But I'm not talking of them today, but they are very rarely, but they are used. Okay, so get should be, or is recommended to be used. Okay, this is, we don't have to be used for reading. I'm sometimes using get for deleting. Okay, I'm not following the recommendations. Most of people, most of REST services are not following the recommendation. Okay, so this is bad. This is nice. Why nice? Because I could do what I need. I have a flexibility. I have a kind of the freedom. Okay, big freedom compared with the XML. So, but the idea was get, read, post, create, put, update, delete. Okay, so the most typical operation done on some data. Okay, some representations. So used methods to describe verbs, what you want to do. Develop technologies, ready technologies, use them. Okay, so as an object-oriented programming, everything is an object. As an service-oriented architecture, everything is a service. So in REST, everything is a resource. Okay, so customers, locations, items, whatever you are doing is a resource. You are accessing it, you are changing its state, you are removing it, you are adding it. Okay, so if I want to play with resources, I need to identify them. So resources have names. Okay, so how to name something? Use already developed tricks. So use URIs. Okay, this is the name. Customers, Coyote. Okay, this is the name, just the name. And okay, just refer to my previous statements. Links have names on web pages because they define resources. And now, in more abstract way, from the programming way, not for humans really, they have names. Of course, names are developed by humans. Resources supports some operations, some simple verbs. So you could create a resource, you can read the resource, you can change the resource, you can delete the resource. How to do it? Use different methods. post, get, put, delete, because this is the capabilities, they are capabilities of HTTP, which is the base idea behind it. And the next principle of the REST, again, heavily connected with the HTTP protocol. Each resource have a representation that should be described using so-called MIME types, that elements inside HTTP protocol. Text HTML, please answer me in text, please answer in XML, please answer in PDF, please answer PNG, whatever, okay, is capable the server, I could ask it for. Okay, of course, if the server is not capable of generating PNG, he will answer with the error. Okay, but if the server is capable of doing PNG stuff, okay, he or she will answer like that. Okay, via formats now, you can notice these formats are somehow or very connected with web pages, but you can extend it to anything. Feel free to use anything, okay? I am very often using JSON, of course, but sometimes application/JSON, but sometimes I'm answering in CSV. I standard, all 60s or even 50s, comma separated files, but nice from some data. I've told you that I was talking yesterday with humanists, but I'm cooperating with them. And unfortunately, it's hard for them to open JSON on their computers. Even CSV is hard because it's not well defined, and there are a lot of tricks in opening CSV. So it's nice for coding, but not all computers. CSV has no information about encoding, etc. So sometimes when, for example, one of our, I don't know, maybe Educacja CL or other system was also responding CSV, it was not opening in the Microsoft Excel correctly. So what I am doing, I'm answering in the Microsoft Excel format, which is a kind of the standard, which is, by the way, XML, zipped XML, but does not matter. So feel free to provide the response in a required format. So now I don't have to convert images like PNG into XML. Why to convert into XML? It's terrible because SOAP was XML. So it is open to any format. Binary, text one. So it's nice, you are free, but of course freedom has too much flexibility, so it also raises problems. So wow, again, the same picture today. Just, okay, it is for the purpose, okay? That's why I started with 3 elements, and now we have 3 elements, but now slightly different, but you will see. So we have names, we have verbs and representations. Names, verbs, representations, and representations. Okay, I don't know how are you aware of the HTTP protocol. You should be, by the way, but post, get allows you to download, upload some data. So in get, you are stating the representation of data on the server side. But in post, you could also send some data to the server. So you have a representation of the input data and representation of the output data. So there should be not a triangle, but I should add a optional 4 elements of that picture. Okay, but why it is important? Next week, I will talk about how to implement it. So how we are implementing functionalities in normal, typical programming languages. We are making objects, we are making methods, and really the functionality is the method. So finally, all that ugly, funny, nice stuff will call a given method. So the server has to know which method you as a client you have in mind. Okay, so really the verb, the representation, the name, has to define a method. Okay, so what is a tricky part and that causes very often errors is that mapping is not correct. It does not have to be one-to-one mapping. Very often is many-to-one. Okay, so for example, two different representations points to a given method. Sometimes if you will not state the representation, all representation will give to the method. Okay, but if you incorrectly state the representation on the client side or incorrectly define the representation on the server side, and it will not match, you'll have an error. Okay, so be careful that most of the practical technical problems that you get a 404 answer from the server is caused by wrong mapping. Okay, so I will come back to that stuff next week, but you have to remember that technically speaking, at the end, you have a method. So you have to map all that elements that are inside HTTP into programming language stuff on the other side. Okay, so let's finish our lecture with some cartoon. Okay, I know that 7:30 is a hard time, early morning, so I hope you will enjoy the example. Okay, so customer wants to update his order with a given company. Okay, at least when I was a child, that cartoon was very popular. Okay, so we have Coyote, and if somebody was watching the cartoon, he or she knows that Coyote loves the rockets. Okay, but let's see. Okay, so the Coyote wants to access his resources. So access, read resources, therefore get. Okay, and the resource has a name. So Coyote is a customer, so customers Coyote. Okay, they are human readable mostly because they are designed to be used by humans as links or as calls inside the code. But who is developing the code? Me or you, humans. Okay, and the response, and this is the get. So get has no data. Okay, it's not true. Get could also provide data, by the way, because we have some functionalities like adding a question mark here. Okay, this is an element of HTTP, so you can provide data. Even the address is a kind of the data. Okay, but for simplicity, we'll state it does not provide data, just points to a given element. Address is also a data, so you will notice next week that I could slash and add here some elements, and that element will be treated by the software on the other side as not as the link, as the name of the resource, as the parameter of the resource. But let me today show it as clean as possible, and all the tricks, all the nice and ugly stuff from point of view of clarity will be shown by me next week. Okay, so the Coyote has a representation, and let's assume that the representation is in XML. Okay, again, ugly XML. On the other hand, compared with the stuff shown by me today, I mean SOAP, wow, it's clean. Okay, because no extra ugly stuff from XML SOAP. On the other hand, wow, what is the type of the name? How to know that portrait is a URL? Okay, you have to know. Nobody is defining it. It's just an agreement between them, and no written agreement. Okay, just spoken one. So tricky part. Okay, but let's move forward. Time is passing by. So Coyote wants to update his orders. So he has to list his orders, all of his orders. So the Coyote gets the orders. How to know that orders are behind Coyote? Have to know, or sometimes in the answer, you can notice it was a tradition, a recommendation to state the next possible links into the answer, but I never ever I'm doing like that, and quite rare I'm using some REST services that are doing like that. Okay, so now you have recommendations, but reality is free. This is a nice element of the REST. Do whatever you want, do whatever you like with all the side effects. So again, get again the answer in some format, XML, and again here I have the list of all my Coyote orders. Okay, so we have the unique ID of the order that could be used for next call. Okay, so again, boring stuff. Again, we have call with get with orders, and suddenly we have the values that are required for the communication. Okay, for the stuff. So we have the order. Okay, and the quantity is 1. Okay, if somebody was watching the cartoon, he or she knows that 1 rocket for the Coyote is not enough. So now the Coyote wants to change the order, wants to update the order. So the now put is used, not get. Okay, and the Coyote sends the updated example with change value. Okay, just notice that we have to change all the values. So there are tricks, different tricks how to avoid sending everything, especially when it will be large. But okay, I'm not talking about them. So this is a very clean example. I will say didactic. What I mean by didactic, nice, show something, but not real. So it is simple, as you can notice. It's just a usage of already developed technologies. I mean, links. It's resource-centric, only few apps, 4 at least. Very scalable. Okay, how to discover the resource? We have names. If you know the name, the resource is discovered. It is stateless. If it's stateless, it's scalable. Okay, load balancing, etc. Already developed stuff, caching, and everything was already developed on the market could be used here. So it was even not a step; it was a small step. Get and post in practice are mostly used. Put and delete are rarely used. We have tools, libraries from all of the languages. If not, opening a TCP connections is simple. You can even develop a REST client from the shell. Okay, wget command available in many shells. If you have a rare situation that there are no HTTP class, whatever representation, probably you have TCP IP. HTTP is simple. Get is text-based. Okay, so opening the port, sending get something, and you have a client. Okay, so really add client capabilities to any application is just, even it could be done in Prolog. Okay, the most strange language I ever use on the earth. Okay, now I'm not saying it's the most strange language on the earth. It is the language which I was programming in. Okay, among languages I was using. So it is possible everywhere. Okay, pure REST is rarely used. Okay, but we have variation on REST. Okay, get, post, returns, JSON with complex structure. So let's try to compare which one is better, XML or JSON. Okay, this is a stupid question. No one is better. No, I can say which one is popular. But so let's compare them. What are similarities, dissimilarities, and why that one is used or the other is used somewhere. XML is text-based. It really has a simple set of rules, just 1-2 slides. We have XML schema, so we have a language that allows us to validate if the given XML document is correct. Okay, I don't know if we are aware, but some of experiments done mostly on students, okay, or with the usage of students, shown that experiments from 80s, 90s, early 90s, that around 70%, from 60 to 70% of typical code consists of validation, checking if data are correct. So if some part of it could be done automatically, it's nice. So XML schema, it's very exhaustive standard, but tools are available almost everywhere. It allows to check the structure of the data, okay? It's not doing everything. I was involved in some project and I was paid for it to add some extra validation, just not given by XML schema to some XML data, okay? Because XML schema allows you to check, I would say, something which could be seen as a syntax, okay, not the semantic, okay? It's checking the types, the values, simple relations, but it does not allow, for example, to check some relations between different elements of the document, okay? If something is like that, then something should be different. This is not possible. So not all possible requirements could be checked by XML schema, but still a lot. On the market, we have tricks, code generators, XML serialization, who have had, they exist for many, many years. JXB, for example, so it is easy to automatically convert XML into objects, objects into XML, and types, classes into schema, schema into classes. A lot of tools, nice things, everything could be done. Problems, memory and CPU consumption, and the biggest problem, I will say, JavaScript. Okay, JavaScript is everywhere at the end of almost each application, and sometimes even inside applications. So this is the language which has to be considered, okay? And it's a slow language, so XML is hard for it. That's why the next solution, which is now very popular, especially in context of REST, however, REST could also be used in the context of XML and anything else on the earth. So again, text-based, much shorter than XML, because this is literals from the JavaScript. It's an element of the JavaScript language, a simple, very simple language that has only few types. It produces a lot of problems, really. Simple problem? Data. Okay, XML has more or less the same problem, because data in most of languages is just a string. Okay, so we can, I mean, JSON, XML, in that sense. So data are different. Okay, so it's terrible stuff. You have to fight it very often. Okay, JSON has a technique quite similar to XML schema, which is called JSON schema, but it not became popular. It's not used as a standard. So it is still being in development, and it's, I will say, that in the sense that it's not hot, not used, only few tools are available. But at least it could solve a lot of my problems I have with JSON, but it's not so commonly used. So on one hand, as you can notice on that slide, these two formats, not the only formats, could be other formats, and one of them will be presented by me at the beginning of the next lecture. But at least these two formats used in distributed programming and REST, for example, are quite similar. Okay, because text one based, okay, different notations. This is the JavaScript. This is a markup language. Well, what difference? Okay, JSON is slightly shorter because it is not closing tags, and it is more close to programming language because this is an element of the programming language. Okay, it looks like even a Python code. Okay, dictionaries in Python could be stated more or less the same. Okay, so why we are now using JSON? Because it is more popular. Good, this is the answer. We are using popular things, but there are some reasons. At least my idea, at least my experience, because I remember times that JSON was not used. Okay, and then I noticed JSON and I'm using JSON. And for computer-to-computer communication, I quite rarely using XML. I'm using XML, but mostly due to its standard for preserving some data for ages. Okay? We as helping humanists, we are also responsible for some digital formats, and we are storing a lot of data. I know. So sorry. Unfortunately, I was asked a question. So okay. So the time is past. So we will continue the problem next week, but it was almost the last slide. And so what will be the next week? Other formats, and I will show how to go to our techniques, replace HTTP by something else. And next, I will show you how simple it is to use in practice. Okay. So thank you very much for your attention, and see you next time, or here next time. Bye-bye.
Thank you.
Thank you.
Thank you. Have a good day.